Welcome viewers, in this video we will see the solved problem based on the transformer on load, the part 2. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the problem. A single phase transformer with a turns ratio of 440 bar 110 voltage takes a no load current of 5 ampere at 0.2 power factor lagging. If the secondary supplies a current of 120 ampere at a power factor of 0.8 lagging, calculate the current taken by the primary winding. So the voltage is given, the no load current and no load power factor is given, and the loaded current and that power factor also given. We need to find the current taken by the primary. So by analyzing the given data, the V1 equal to 440 voltage. The primary voltage is 440 voltage and V2 is 110 voltage. Then I0 is 5 ampere, no load current. For that the power factor cos pi naught equal to 0.2. Under the loaded condition, the current taken by the secondary is I2 equal to 120 ampere. For that corresponding power factor cos pi equal to 0.8. So the voltage is available, no load and full load current also available. We need to find the current taken by the primary winding. So from this cos pi naught equal to 0.2. So that pi naught equal to cos inverse of 0.2. So that value is 78.46 degree. Similarly, cos pi 2 is given, that is equal to 0.8. From that pi 2 equal to cos inverse 0.8. So the cos inverse 0.8 is 36.86 degree. So now we got the value of pi naught and pi 2. Now we'll see that the I1 square, the primary current. The question is we need to find the primary current. That is nothing but vector sum of I0 and I2 dash. Vector sum of I0 and I2 dash is nothing but primary current taken by the primary. This I2 dash can be calculated as K into I2. This I2 is given in the problem, right? So the I2 dash equal to K into I2. Then how will you find the K value? Transformation ratio is V2 by V1. K equal to V2 by V1. V2 is 110, V1 is 440. So that 110 by 440 equal to 0.25. So the transformation ratio is 0.25. Now we got the transformation ratio, so that we can calculate I2 dash. I2 dash equal to K into I2. So the K value is 0.25 is calculated into I2 value is 120. So by simplifying that we got 30 ampere. The I2 dash, the current due to loading of secondary is called as I2 dash, that is 30 ampere. So based on this value we can draw the vector diagram. So this V1 is taken as a reference. The voltage in the primary winding is reference. The pi is out of 90 degree out of phase with V1 because I mu, the magnetizing current, is responsible for producing this pi. That magnetizing current is lagging the voltage by 90 degree. So that in this x axis we are taking the value pi. So the no load current I0 is 5 ampere. No load current is I is 5 ampere. For that the corresponding angle is 78.48. That is we calculated. From cos pi naught we calculated the pi naught value. So this angle is 78.6 degree. Then I2 dash, this I2 dash is 30 ampere. We calculated I2 dash is 30 ampere. So that is the angle is pi 2. Pi 2 equal to 36.86. So that also we calculated from the cos pi 2. Right. So I2, so I0 is no load primary current is 5 ampere. That is at an angle of 78.6 degree. That is calculated from this pi naught. And I2 dash is 30 ampere at an angle of 36.86 degree. That is calculated from the cos pi 2. Now this I1 is nothing but vector sum of I0 and I2 dash. Vector sum of these two. So this angle, the difference in angle between this I0 and I2 dash is calculated as 41.6 degree. So that also available here. The angle between I0 and I2 dash is the difference between these two angles, 78.6 minus 38.86, that is equal to 46.6 degree. So that can be taken as theta. The angle between I0 and I2 dash calculated as 41.6 degree. From the diagram also we can calculate. So from this angle and the I0 value and I2 value, all the values are available. So easily we can calculate the I1 value. The I1 is nothing but vector sum of I0 and I2 dash. What is I0? I0 is the current flowing through the primary under loaded condition, no load condition. I2 dash is the under loaded condition. So vector sum of these two is nothing but the total current I1. Then how will you find the I1 value? Using the parallelogram theorem of vectors. I1 dash I1 equal to square root of I0 square plus I2 dash square plus 2 into I0 I2 dash into cos theta. So this is the formula available for using the parallelogram of vectors. This I0 value is available, I2 dash value also we calculated, and this theta, cos theta, theta value also calculated. The angle between this I0 and I2 dash. Now substitute all the values. I0 is 5 ampere, so 5 square. I2 dash we calculated 30 ampere, so 30 square plus 2 into I0 is 5, I2 dash is 30 into cos theta. The theta value is 41.6 degree. So by simplifying this for all this value and taking the square root, we got 33.9 ampere. The current taken by the primary, the total current taken by the primary is 33.9 amperes, right? So from this vector diagram we can easily calculate. So this I1 value is 39.3 amperes. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.